video is about a small project that I'm doing to complete the operation of my oil heater, and it consists of I call it a manifold. It is actually a wall attachment that terminates the oil lines that feed the oil into the funnels. In my case, the funnel sits on the stove, a bit away from the wall. So I wanted something that was rigid, so that the oil does not fall or drop next to the funnel, because that over time becomes incredibly messy. And besides, I want it to be somewhat secure. Of course, the oil should also not drip on the stove. I don't think it would catch fire immediately, but it certainly will stink. And what I also would like is that this wall attachment can be retracted or moved against the wall when I'm not using the oil stove. So I will show you the plan for this next. I have made a very small drawing, and I also have a preliminary setup that I can show you. So, the way this works, for as far as explanation is required, there will be two inlets for fuel. One is the fuel that comes from overhead. That's the thinner stuff, which is always liquid enough to heat. But next to that, I'll have a second inlet where I can feed in the greasier stuff, which needs preheating. So in order to accomplish that, I'm simply putting a can on top of the stove, where it will be heated up to, let's say, 100 degrees Celsius or thereabout. That makes it liquid enough to flow through a piece of tube, which will be attached like so. My arm in the way, of course. It will be attached here. What I have also done is both holes are M7, so I can put in a valve here as well, but for now I'm not planning to do that, because I think it will clog up with the thicker fuel. So what I have done to have at least some control over the fuel flow is I have drilled a hole through with M10. The plan is, as you have seen perhaps on the drawing, that from the back side I will plug this hole with a bolt, which is just long enough to end up where the internal hole starts. Actually, that's when you look at the drawing, it's like so. So the bolt will sit here. It will end where the hole for the fuel inlet, it will come up to the edge of the hole of the fuel inlet. Then on the other side it's also threaded, and there I will put in another bolt, which is somewhat longer, but because I will turn the faces here flat, it will be possible to turn in this bolt up to the face of the bottom one, and that will for all intents and purposes close the fuel flow from this oil line. So right now this is the wall attachment. It comes from an old office chair where it was actually the back seat, or the connection between the bottom and the back seat. This is 5mm or perhaps even 6mm steel, so it's plenty rigid enough. The stove or the heater will sit somewhere here, the funnel here. So what I'm going to do is I'm going to have this leftover piece of aluminium screwed into here. This is the manifold on a piece of rod, square, tube, that will sit underneath at the right distance, and which means I can adjust it both in the length and like here, and like so. I can turn it so it will always be possible to have it exactly where I want it, and if I don't need it, it goes there, and I'm also good. So that's the plan. So this is the bolt for the backside of the manifold, which I'm going to turn down to size. It should be 7mm. So here I've got the bolt in the lathe, which is going to act as the valve, let's say. This one does not need to be shortened, but I do have to make the bottom flat, like with the other one, to make sure that that it closes the oil flow well enough. Since it's really nice weather out there, it's a good time to do something in the shop, and this is the start of the oil manifold, or the oil inlet manifold, whatever. It's simply a stable mount where I can terminate the hoses that feed the oil into the oil burner. So I'm going to make it out of aluminium, a square stock. This is 22mm, and as you have seen on the drawing, I'm going to drill a hole from one side, M8. So currently I already centered the hole with pre-drilled the hole with a center drill. This is a 6.8mm, which is the tap size for M8. I'm going to run that now up to a depth of 16mm.
nice stringy chips of aluminium. Since this drill is not so big, they are not so so sharp and so mean as the ones I produced a while ago, when I had to drill a somewhat bigger hole. You can cut yourself fairly easily on this kind of chips, but in this case they are quite gentle on the hand still. Okay, that was one hole. Now I'm going to move the table 30 millimeters. I'm prepared for the next hole. Looks like I missed one, or I counted one too less, because now it's exactly where I marked it, so this must be the right spot. I'm going to try to drill even without using the spotting drill. Like a charm. That's it. Two holes done. Now I'm thinking what the plan is. I could go ahead and tap this already for M8. Actually, I think that's what I'm going to do. Actually, I'm going to turn it over and drill the holes on the opposite side first. We'll do the tapping at a later stage. That looks alright to me. Certainly good enough for the kind of work we are doing here. This baby is not needed. So since I didn't move the table in the y-axis, it's still centered. So the only thing that I need to align is the x-axis. And it looks like I'm quite nicely on my hole now. Like that. So from this side we are going to drill for M7, which happens to be a 6mm hole. And we are drilling until we meet the other hole, which is supposed to happen at a little over 5mm depth. I don't even think I ever used this drill before, because M7 is quite an exceptional thread. I need it for this. Let me see. This is the valve for the oil, and I have been I've spent quite a while to find out which thread it was, and it never crossed my mind that it could be M7, but when I failed miserably with a quarter 24, I found that M7 apparently was a fit, at least that I could get it in there, and then yeah, turns out that it's simply the right thread. So that's said and done. We're going to drill these two holes. Actually, I'm going to mount only one of these valves, but for the sake of uniformity, so that I'm eventually able to switch or mount the same valve on the other side, I'm going to process both holes in a similar manner. Okay, I can see that I'm through now, but because the holes are not completely aligned, it is now a bit hard to drill further, because the drill wants to draw towards the bigger hole from the other side. So I'm going to move the table back, and without center drilling, I'm going to move the table back and without center drilling do the other hole. That was 24mm. We double check that. And again, this is not a job that requires 200% accuracy. 24. I think. Yes. So same thing here. The drill actually wants to drop towards the larger hole, which is not directly underneath this one. So yeah, I'm stopping here. So now it's time to start tapping these holes.